for lesson 12 is basically like we just did when we practiced. It says, choose the reasonable product for each expression and explain your reasoning in the spaces below using words, pictures, or numbers. We're only going to explain one of these, okay? Just so you can practice writing down your thinking. Okay, so the first one says 2 5/10 times 4. So 2.5 rounds to what nearest whole number? 3. So write down 3 times 4 equals 12. And find the answer closest to 12. 10. Okay, now explain what we just did. Jay, what did we just do?
We just multiplied 4 times 3. And,
Well, where did we come up with the 3?
Rounding the 2 5/10, and so we multiplied them and got 12, and then you just kind of whichever one's closest to 12, you would.
Okay, so did we estimate?
Yes.
Yes. So I'm going to put I estimated by rounding two 5/10 to the nearest whole number and multiply. Good. To find a, and I was going to put an answer that's close, but then I decided, no, let me just pick out some words from my problem. I'll sound smarter that way. So as multiply to find a reasonable estimate, or do you want to use product? Product sounds better, doesn't it? Okay, and then I'm going to read this back. Now, that's using words, right? And it says you can use words, pictures, or numbers. We sort of used numbers too, didn't we? If we would have done this, that might have also told some information. This means to
Estimate.
round, right? Round. Okay, so another way to do this, I estimated by rounding 2.5 to the nearest whole number and multiplied to find a reasonable product. Okay, makes sense. What's another way I could have done this without words? Julian? The vertical number line? Yeah, I could have drawn the vertical number line to show that I estimated by rounding. Okay, is there anything else I could have done?
Yeah.
What?
The area model.
I could have done the area model, but on the area model, that would have given me the actual answer, and I don't need it. So I think the area model is too much work for this. What do you think? You could have drawn a tape diagram to show 3 times 4 if you wanted, right?
I see that.
3 groups of 4 looks like this. So you could have drawn that. Okay, so let's go down, and the rest of them we will not explain, we'll just work through. So take a look at B. 3.14. I'm just looking at 3.1. Does it round up or stay the same? So I've got 3, write this down, 3 times 7 equals?
21.
So which answer is closest?
21.98.
21 98/100ths. Okay, you want to try the next 2 on your own and then we'll check them? Okay. Make sure you write a problem so I know what you're thinking. Okay, so when your pencil's down, I'll know you're ready. Okay, so 6 and 22 thousandths rounds to what, boys and girls?
48.
6, right?
48.
So you got 48,
176.
6 thousandths. Very good. Okay, 5.48. Now they're trying to trick you.
9 times 5.
9 times 5, because 5.4, 4 is below the midpoint.
And then you got 49 and
45 is what, I'm behind you, Blair.
49 and
Okay, so you think you know what to do? That's all your exit ticket is. Pretty simple, huh? Okay, let's do a couple problems. I think we need to challenge our brains. I know. Not always, though. You sometimes have to round. Oh, I see what you're saying, yeah.
It's 9 times 5.
Yep. Okay, so there's 2 ways to do this problem, and I want to talk about both ways.
Bring it on.
Now, me being a perfectionist, I would probably do it a little bit differently than someone who just wants to save money. Okay? So let me read this, and then we're going to talk about the 2 ways. Pedro is building a spice rack with 4 shelves that are each 5/500 meters long. At the hardware store, Pedro finds that he can only buy the shelving in whole meter lengths. Exactly how many meters of shelving does Pedro need? So we need to know exactly how many he needs. And then, since he can only buy whole number lengths, how many meters of shelving should he buy? So we've got to do it 2 different ways. We've got to find the exact answer, and then we've got to decide how much to buy. Okay? So the exact answer, what's the best way to figure that out?
Area model?
Probably. Okay? So we could also do standard algorithm and change it to unit form. Would you like to do that instead? It's a little quicker. So if I change 5/500ths to unit form, I just take out the decimal, right?
0.55?
So I just write 5/500ths. And how many shelves does he need? 4. So multiply it by 4. And then remember, you're going to write your answer with hundredths, and then we'll have to change it. Okay, so 5 times 4, what is it? 20. 5 times 4 is 20 plus 2.
22.
Okay, now this is showing hundredths here. So how many place values will I underline? 2 place values. So where will I put the decimal then?
Between the 2 and the 2.
No.
Between the 2 and the 2.
Between the 2 twos?
Between the 2 twos, yeah.
Okay, so he needs 2.2 meters of shelving, doesn't he? Okay, so we've got exactly how much he needs. But he can only buy whole number lengths, so he can only buy like 1 meter, and 1 meter, and 1 meter. So how many meters would he need to buy since he needs 2.2? You say 3. What do you say, Daniel? 3. It has to be a whole number. And if I buy 2, then I don't have enough, do I? So how much does he, this is exact, and this is by, okay? So you're saying 3 meters is what he needs to buy, and you're correct. Now, I'm a perfectionist, though. Yeah. And since each of my boards it needs to be 5/500ths of a meter, that's a tiny bit more than half. Right? It's a tiny bit more than half of a meter. So I'm going to draw this for you, okay? And let's just say the shelves look like this. Okay, so that's like 4 shelves, okay? And each shelf is how long? 5/500. So 5/10 would be half, so it's slightly more than half, okay? Why would I want to build a spice rack with one of these shelves cut in half or pieced together? Wouldn't I want to buy 1 meter for each shelf and then cut off the scraps?
Because there's 2 units left.
You see what I'm saying? Are you following me? If we do it this way, so they're going to have to do 55 hundredths of a meter, and then they'll have to do almost a meter, and they'll have to put another board right there to do a little bit more, and then so they've got a cut in this shelf. They're going to have to like nail it or glue it together. Why would I want to do that when I could just get 4 boards and cut them almost in half and put it on there? How would you rather do it? Would you rather do it the least expensive way to save money? Possibly. But if I'm building something and going to all that work, would I really want a seam? It's called a seam in my shelf.
No.
Not really. So there's kind of 2 ways to think about this, okay? This is the actual answers to the question, the way it was written. But in the real world, I think I'd probably just spend a few extra dollars and get another board. What if they're like $12 a piece?
I don't care, I'll buy it.
That would be worth it to me to not have to piece those shelves together. See what I'm saying?
Yeah.
Okay. Now, if it was 5/10, then that would be a no-brainer. We would cut each meter in half exactly and make 4 shelves. But it's not 5/10. Okay, I'm going to go ahead and stop the video there so it doesn't get too long.